वैसे तो 50-50 में 55 इंच के टीवी भी कैसे बनाना यहाँ पे कोई यूज ही नहीं करता यामाहा का स्पीकर लगा के रखना है तो किसी को सुनाई नहीं देगा I don't know some settings if you are all the sections they will come near the TV and speak because that is the speaker that's connected. And as long as you change the speaker to the one that we're sitting and talking is against the mic is not speakers. Speakers are good, the mic is not. Yes, correct. Xbox speakers.
Hello everyone. Welcome to the 38th edition of GeekNight. I think most of you are frequent attendees of GeekNight. But for those who are new, GeekNight is a community-driven event that happens first Wednesday of every month, where technologists come together and share their knowledge on latest trends and technologies. Today we have Sreedhar Joshi to talk about the blockchain. Sreedhar has around 15 years of experience and he also has interest in developing scalable software and data engineering. He's also the speaker for our first event. So with no further delay, we'll get started.
Can you all hear me? Loud and clear? Can you all see this screen? Cool. Hello all, welcome to ThoughtWorks for yet another edition of Geek Night. Right, as Jan mentioned, this is a recurring event. It happens on every first Windows Day of the month. Cool. I was exploring this space called blockchain. Got introduced to it, like most of us, using Bitcoin. So when I started understanding what Bitcoin is, then I got some information about Ethereum. That got interested, and then I said, okay, let me explore this space. I started exploring, found it really, really interesting. So I thought it's a great platform to share and learn from each one of you. That's the whole objective behind this talk, right? Let me. I think fixing the mic is difficult, so getting the technology right could be more difficult than that. So this is what I intend to cover in this talk. So where I got this from, I've requested my colleagues in terms of what they are interested to understand about blockchain. See, these are some of the responses that I got. So I kind of club them and try to kind of project it so that you know is their expectation right. Right? You still have time, so if it doesn't match your expectation, then you can always walk out and you don't have to waste your evening. Alright? So the first one is why is this buzz around blockchain? The recent times, what are some of the misconceptions prevalent in blockchain? And new to crypto world, what if I don't care about the blockchain? So the first part is about basically the buzz around blockchain. You want to understand why this buzz around the blockchain. Now the second bucket is what are bitcoins, what are the pros and cons if country supports a crypto-based payments. Second bucket is around cryptocurrency, right? We'll kind of try to talk about that. Third, right, is about what is the scope of a blockchain, business scenarios. It's all about cryptocurrencies. Can I do anything beyond cryptocurrencies, right? So the third one, and it also talks about the ICOs. Right, so the third one is about application of blockchains and how do you actually say a blockchain is useful or not. That's the third bucket of questions that we have here. The next bucket of question is I'm a developer, what should I do, right? Are there any existing real-time applications? How can I start a project? I'm a part of tech industry, what should I learn? Right? More dev-centric questions. And the fourth one is some specific questions about what is mining, what is a transaction, and those are the kind of questions. Does that sound okay? Those are the expectations that you have, or any other expectations that you have. Had a few conversations before the talk. There were some good use cases that I came across, but this is a good opportunity to talk about any interesting use cases that you're thinking about. Does that sound okay? Cool. So we're gonna spend together another 2 hours, right? So let's make it interesting. So participate. If you have any opinions, please share it. If you have any disagreements, please air it. Right? I'm not the master of the stuff here, so I'll be happy to take your viewpoint. What is the target audience? Right? So if you put a slider between novice and a ninja, this would be more towards novice. Right? It's not a talk for people who understands Bitcoin really well and advanced topics. So this is at the beginner level talk. We will go from grounds up in terms of what this whole stuff is. We will disassemble them and try to assemble that so that we understand what's happening behind under the hood. Right? That's the target audience that I'm looking at. Anybody who has good Bitcoin, probably they'll be able to join in and add their views. So cool. We'll start with fundamental concepts of how the blockchain got built. Sorry, I have a sore throat, so I'm using a step. You would have to bear with this noise. Right? So all the technologies that we are talking about in blockchain, right? They existed for decades. It's just that we kind of got them together and created this recipe, which is we are calling blockchain. So what are the fundamental components of that recipe, right? So one of the fundamental components of that recipe is one-way functions. Anybody wants to give their viewpoint about what do we mean by one-way functions?
Hashes.
You don't have to be right. If you have an opinion, it will be a useful conversation. It will be a conversation, otherwise it will be a monologue. Thought workers are also allowed to participate, so don't hold yourself back. One-way functions? Any idea?
Hashing.
Right, hash is an implementation of one-way function.
Yeah.
So what's the characteristic of a one-way function?
You cannot get it back.
So execution of a function from one direction to other direction is easy, but the inverse is not easy. Finding an F inverse is very difficult, right? That's the concept of one-way function that we saw here, right? So trapdoor is a good implementation of a one-way function, right? Opening the door is easy. You can't kind of push it back that way.
It's like a one-way route.
Sorry?
It's a one-way road.
It's a one-way function. You know, in this concept, one-way road. Yeah. Okay. So one of the applications that we talked about is hashing, right? One of the very critical component of the whole blockchain and Bitcoin, right? Hashing plays very important role. So hash function is a function which takes an arbitrary length of string and creates an output which is fixed length. And from the fixed length string, you can't get back the original string. So it's a good use case of a one-way function, right? The important characteristics of this, it always gives you back a fixed length string, and you can't kind of engineer it back. And even if you change one character of a string, your hash would look very different. You can't predict. You can't do a pattern matching on the output and identify the input, right? So you can't kind of keep changing characters and watch the output, do some pattern matching, and try to guess the input. It's very difficult, right? Everybody with me on that? Because this plays very important role in Bitcoin, right? An example of where this is useful in your addresses. You have a Bitcoin address, you use hash function, right? You have a transaction ID, we use hashing. So hash plays a very important role in the whole blockchain ecosystem. Am I speaking too fast, or you able to follow me? This space is okay?
Yeah. Okay. Yeah.
Okay, yes? Cool. The second important concept is called Merkle tree, right? This is a data structure, right? Sorry, I think I missed this when I was about to start this. How many of you are technical? When I say technical, each one of us are technical, but how many of us write code to live? Most majority, right? Some other hands that did not go up are in the tech space, but they don't write code, right? So if you think any of the stuff that I'm talking about doesn't make sense, please raise your hand, right? Don't have that inhibition that you're in a crowd who understands programming, right? So if you don't understand, please, because you're going to spend next 2 hours, make it valuable. Let's understand this concept called Merkle tree, right? Merkle tree is basically a data structure, right? Data structure is nothing but a structure of data which has an characteristic. So what is the characteristic of a Merkle tree? So you have this some text here, right? There is some text. What you do is you hash this text. We understand hashing, right? Hashing is basically converting a piece of string to another piece of string, right? So you hash this, and what you do is you hash both the hashes, right? So you got a hash, you hash them together. You get one more hash, right? Similarly, you get one more hash this side. Then you hash this and this, you get the root hash, right? So now this is the beauty of the Merkle tree, right? If somebody modifies a character in this, what would happen? Yeah, this hash would change. Because this hash changed, this hash would change. Because this hash changed, this hash would change. And you can always trace back to which actual string that got changed. That's the beauty of this data structure, right? So if I just have this Uber block, I can always know that somebody modified the data or not. Right? That's how we use Merkle tree. And where does this get used? You can find chairs. There are some more chairs here. Right? So yeah, where do we use this? We use this data structure in a block. We will talk about what a block is. But basically record all the transaction that happened in a block. We use this data structure. Right? When we go there, we will talk about it. But just understand the concept that this is the Merkle root. Clear about that? Any questions? You got that? Yes, no, maybe, yeah. If you have the tree, right, or the original tree, you know the hash that got changed. So you can always trace that. Okay. Yeah, otherwise, if you only have one copy, you can't. Yeah. Any more questions? You got the question? The question was, how can you trace back what got changed? You can only trace back when you have the original copy and the clone copy. You can trace back, yeah. Apart from the? I don't know if it will use Merkle tree because it would use hash. You give you a piece of code, it hashes it, and it identifies that this piece of code has this hash. So if somebody modified it, the hash would change. But I don't know if I would use a Merkle tree to store a Git. Okay. Do you want to talk about how do you think it gets used? The Merkle tree. Okay, fair enough. Do you want to share that with the audience in terms of, do you know the specifics on how does that get? Okay, fair enough. Okay, cool. Yeah. Yeah, if you know some cases, right, please feel free to add. The third concept that we need to understand is the public-private key cryptography, right? As this diagram depicts, you have two keys, the public key and the private key, right? So if you encrypt a data with one key, you can decrypt the data with other key. That's a basic concept of public and private key. Clear with me? So you have a piece of code, piece of string. You use a key to encrypt it. You can use the other key to decrypt it. Where do we use this in blockchain? We use this in blockchain to sign a transaction, right? So for example, Joseph transferred me 20 bitcoins or ethers, right? Now if I want to spend that bitcoin, I need to prove that I am the Sreedhar. How can I prove that? I will use this technology. We'll talk about that when we go to details, but this is used in kind of claiming your crypto coins. Clear about this? Is this too basic for most of you?
Yeah.
Okay, cool. We will kind of skip them through fast. Now we arrive at the data structure called blockchain, right? So what is a blockchain? Blockchain by the name, it's a chain of blocks, right? Each of this is a block. And you have a chain of blocks. And how do you trace this? You always store the previous hash of the block. That way, if I'm here, I can always know what is the previous block. If I'm here, I always know what is my previous block. That way I can trace it back to the genesis block, which is your root block. Right? That's why it's called a blockchain, because it's a chain of blocks. And we talked about the Merkle root here, right? So we store the transaction root. We talk about each of that in a bit. We will talk about each of the components when we go into the further details. But it's basically a data structure outside the world of cryptocurrency. It's basically a data structure which is chain of blocks tracing back. Even you can think about this like your linked list, right? You can always trace back to the original block. Cool. Right, so those are the fundamental building blocks which went into building this whole concept called blockchain and cryptocurrency. Right? Now we will talk about what are the characteristics of a good blockchain look like. Right? There was a question, if you go back, there was a question about there are a lot of ICOs happening, right? How do I know whether this ICO will make sense, whether ICO will dump, right? So these are some of the characteristics of a blockchain that's necessary for it to function properly, right? So the first characteristic of a blockchain is it's a decentralized P2P P2P network, right? What do I mean by that? When I say decentralized, there is no central component in this whole blockchain, right? Each peer, each of those nodes are same. There's no superiority or inferiority in terms of nodes, right? And how do they use data exchange? They use some of the P2P protocols to exchange the data amongst them. That's first characteristic of a blockchain. So if anybody is trying to create a blockchain and that's not decentralized, that's a question that you need to think about in terms of how are they solving this decentralization problem. The second characteristic of a blockchain is that it's tamper resistant, right? I think lots of you kind of came with understanding of this, right? So it actually, you cannot change a blockchain once you create it, right? So there's a nice website here which actually demonstrates it. I would recommend you can go back to your home and try this. It's a very good website. Right, so this is the website where they have a blockchain, right? These are the nodes that I have, right? If I have to change, let's say, third node, right? Let's say I have changed this. If you see here, all the nodes following that node got changed because any guesses? Right, so hash got changed. Now, for me to fix this blockchain, what I need to do? Right, I need to go mine this node, right? That went really fast for a change. I need to mine this block. Right? And then I need to go mine this block. That's how I can decide the blockchain history. Right? That's what we meant by it's tamper resistant. Right? It's not tamper proof. I think you need to get that difference, right? We are not saying you can't change it. We are saying changing it is difficult. Right? That's what we meant by tamper resistant.
So this will be a new block.
This will be a different block altogether. Yes.
The old one was.
No, that is gone now. Right? From the chain, the main chain, you don't have the block anymore.
You can't access it.
No, you can't access it anymore. Sorry about that. I'll put this on silent. Sorry? So there's no old chain at all, right? Okay. Okay, let me explain this, right? There's no old chain anymore. So I come here, right? This is what is a public chain. So what do I mean by this is public chain? This is what everybody on the network will see. Right? Clear with that? Everybody on the network sees this. Now if I go and modify something, right? Let's assume there are no miners on the network. And the only miner that is there on the earth is me. Right? There's no competition. Right? So I go mine this now. This gets pushed into your global network. Where is the old node? There's no old node at all. Because this is one copy, one state, global state that is there across the planet. So everybody, the moment I change this, I'll push this to my peers. Right? And those peers will push it to their peers. That way, in soon, every node on the network will see this copy of the reality. There is no old copy of reality anymore. Clear with that? This is, yeah? So I go, I mine this. Now this is the new reality. There's no history. This is the new reality. Right? In real world, this cannot happen. We will talk about it when we talk about mining. Right?
Can you let me know what nonce is NONC?
We will talk about it. We will talk about what nonce is. That's a very important characteristic of transactions. Yeah, we will talk about it. Not transaction, mining. There's nonce in transaction, there's nonce in mining. We will talk about both. But everybody clear in terms of this is a question get answered? There's always one copy of reality. Right? For example, take me. Right? Probably 10 years back I was 25 kg slow. Right? But what is reality? Sreedhar 90 kg is reality. For 75 kg it doesn't exist, right? It's somewhere there, right? So that is the reality now. Yeah.
Once a transaction is created,
No, it can be changed. It can be changed by mining. The question there was, one of the concept was, yeah, you want to ask your question? Yeah, the question was, once you write a transaction to blockchain, we thought we can't change it, but we were able to change it, right? We can change it, but
not delete the old one.
There's no deletion.
Yeah.
There's no deletion, right? It's a new reality.
The path changes.
It's a new reality, right? Yeah. It's not tamper-proof, it's tamper-resistant. The question was, how is it tamper-proof then? We are not saying it's tamper-proof, it's tamper-resistant. We will talk about this when we talk about mining. That question is really, really valid. Mining solves this problem.
You were saying that we are not storing any old data.
Right.
So how you compare whether it is changed or not? Because for comparing, we need to store the old data.
We don't compare. We don't compare. So there is no, we don't compare. What we do is whether we say this block is valid block or not. Compare. Okay, let's take a concrete example, right? In real world, what is the example that okay, let's do a Lego block, right? I'm building the Lego block. I'm building a car, right? Because of whatever reasons, I built an ambassador, right? My son doesn't like ambassador, right? He wants Ferrari. He comes up and changes just to Ferrari, right? We are not comparing that against ambassador. At that point in time, the reality was car is ambassador. At this point in time, the reality is car is Ferrari. Whether it got changed, and if nobody is monitoring it, this is a valid transaction. But because this is decentralized, because everybody is monitoring it, people will say, no, this is not a valid change. You can't change ambassador to Ferrari just because your son asked. Right? We will hold that question. We will talk about it when we go back to money. Everybody understood the question? Yeah. Okay with the response? For now, the only question is how can we make it tamper resistant? Right? Tamper resistant. Yeah.
So in a decentralized system, where does this blockchain actually reside?
Everywhere. All the full nodes. So for example, you can participate in mining. What you need to do is go back, join a peer that is near to you. You can download the entire blockchain onto your disk. So you have the entire blockchain on your disk. Today, the blockchain size is about 13 gigabytes. So if you have network bandwidth and disk space, you can download the entire blockchain and start participating in mining. You can be the full node.
Whatever change I do, it will be communicated across the entire.
Correct. That's mining. Correct. That's right. You can change and you can push it to the main network. There is no central authority who approves your change. It's arrived using consensus. So we'll talk about consensus protocol. Then you will understand how that thing works. Any more questions on this?
So I don't know if this is correct because I was little late. So my question is, as we're talking about mining, so what happens when we start mining? As soon as
have you ever eaten ice cream? Hold it like you're eating an ice cream.
that's fine. I usually don't eat the mining. So when we do the mining, what happens when the mining miners start mining and the block will start formation quickly? Then what happens? The complexity of a particular block, or because a group of work or the zero that is appended in the initial location, it always increases. So my basic question is, at one time we talk about the power and the heat consumption and all, and it is like we have to be a little environment friendly. Why this suppose whoever designed this, why did he increase the complexity bit at the zero every time? Because when we say although this mining, whoever give the POW first, he broadcast the whole message, okay, I have done this, and people verify it, and they made the consensus, okay, and that block goes to the chain. Why increase complexity every time? If he doesn't increase the complexity, what happens? People can mine very easily and efficiently and faster. So that block would have been much faster in the blockchain instead of having.
Sure.
Why did he do that?
Fair. That's a good question. The question that he's asking basically is, I think the question is probably 5 slides away, but his question is, why we design mining the way it is designed in blockchain?
Yeah, complexity.
Complexity, right? We will kind of address that when we talk about mining. But hold on to that question. If you think it's not answered, please bring it back. So his question was, we use proof of work as a concept to do mining, and proof of work is not energy efficient. Alright? And we have a difficulty level, why we can't keep decreasing the level so that your block mining becomes efficient. Yeah, we'll kind of answer that when we go to mining. Yeah.
Just one quick question. You said that I can download the entire application of the
Entire blockchain, yes.
Yeah, onto my computer and I can participate.
Right.
What if I want to play naughty and I don't want to approve a transaction?
Fair enough. But there are other miners who can approve the transaction.
So it is the majority, not everyone.
It is the first who can prove that they have worked. It's not the majority, right? It's again a concept of mining. Let's assume you and I are participating in blockchain, right? And entire room. The only people who are participating is you and me. So there is no concept of majority here, correct? If I am able to mine a block first, right, I can approve the transaction. I don't need your approval to approve the transaction. I don't need anybody's approval to approve the transaction.
So if there are a million users, even one approves a transaction, it is deemed to be approved?
Yes, you have to prove that you approved it. That's where your proof of work comes into picture. And others can verify that you actually worked on it.
Okay.
But the thing is that these guys are 5 translates.
Sure.
Farming, I'm a beginner. So even I see that what is the miner, who is the miner, mining, Bitcoin, and blockchain are not different.
Fair. Yeah, thanks for the feedback.
That's why I want to start.
Sure, fair enough. Good call, right? Yeah, so let's be cognizant of the audience here, right? So let's not jump into slides. If you have a question, please raise it. We will kind of answer it when we go there. That's fair? Can we have consensus on that? Yeah? Okay, cool.
I have a quick question.
Related to slides this and before.
Yeah.
Okay.
So my question is, see, the whole blockchain gets copied onto every node. My question is now, if a transaction happens simultaneously, like many transactions will be happening. Before one node gets updated to a particular address, if 2 transactions are conflicting, how will that be resolved?
Exactly. Question valid. We have a solution for that. So hold on to your seat tight. We will answer that question. That's a valid. It happens almost every day. So okay. So we were talking about the characteristics of a blockchain. So first characteristic of a blockchain is decentralized and P2P based. Second characteristic is tamper resistant. The third characteristic is consensus based. There is no single authority who approves a particular block. It's consensus. People have to agree that this block is a valid block. So it's consensus based. So those are the 3 characteristics of any blockchain. Right? Clear about consensus? We will talk about different consensus mechanisms, but consensus is agreement. The network has to agree that this is a valid transaction. Cool. So this is the other common question that we keep getting. We talk about Bitcoin, which is cryptocurrency. People also talk about different crypto coins. So the question is, can a blockchain exist without cryptocurrency? Okay. How will that work?
Okay.
Some ideas?
First of all, blockchain is not a new technology. Already in 1980 and 1995, the notary system, just like the property related with the property transfer system, is already the concept of the blockchain.
But you can modify papers.
Yes, it is the modified in terms of the we can say it will be the distributed data warehouse.
Okay, but there are some characteristics for that. Those are the 3 characteristics. Yeah, as long as you can get those characteristics, you can deem yourself to be called blockchain. But the question is, why should a blockchain have a cryptocurrency, or why should it not have a cryptocurrency? That's the question. Can a blockchain exist without cryptocurrency? Right. So let's take a fixtures example, right? Let's start a new blockchain called ThoughtWorks GeekNight. ThoughtWorks GeekNight blockchain. The idea is, once I participate, there's a video recording, right? Now that gets pushed into your blockchain, and you cannot go back and edit that, right? For whatever reasons. I want to look much thinner there, I can't go and edit it, right? How many people would mine that? How many people would add that to the blockchain? Who would be interested in adding that to the blockchain? Raise your hands. Could be, you are interested. Why you are interested to add that to the blockchain? Global blockchain? In this use case, let's take this use case. You will not be interested. Yeah, okay. Right? So yeah, as long as you get some monetary benefit, you will be able to. Anybody who, some motivation, right? What could be motivation in this case? Example? Okay, fair enough. Yeah.
Stopping you to editing the video.
Sorry?
Stopping you to editing the video.
Stopping me to edit the video. Yeah. Yeah, you're a control freak and you want to control things. Perfect.
It's a legitimate thing when you want to know what's the sequence of lectures being given in thought.
Okay.
So anyone can not add any other lecture in between.
Okay.
But
yeah. So if you're a hard worker and you're very passionate about the GeekNight brand, you would want to do it. Yeah. Right. But why would you do it? What's in it? Exactly, right? What's the monetary benefit that you want to do? If you want to expend some computer time, you want to express your own time, you don't get it. Right? Very, yeah, that's why I like GeekNight, right? A lot of people with good intentions and open source mentality comes here. Right? That, yeah, it's valid, right? But if you start seeing, right, there's a pattern in this blockchain. Right? People want to get onto the blockchain and do some mining because there's some benefit, right? It could be monetary or it could be something else. So so we can call the cryptocurrency part of the blockchain as a fuel behind that engine, which kind of, it's a motivation behind that engine to progress, right? If I don't have any motivation to participate in the blockchain, the chain wouldn't progress. I'm the only one who would be using it, right? That's a philosophical answer behind why do we need a cryptocurrency behind a blockchain, right? But you don't have to define your own cryptocurrency for a blockchain. That's a pattern that we are seeing, right? Every blockchain on the earth is having their own cryptocurrency. You don't have to. You can use Ether or a Bitcoin as a cryptocurrency for your blockchain. But you need blockchain or some monetary benefit or some motivation behind you progressing that blockchain. Clear about the argument? Yeah? Because that's a question that keep getting. Why are we only talking about cryptocurrencies? Because cryptocurrency fuels your blockchain progression. Cool. So let's look at the transaction in one network and kind of understand what's happening behind the scene. So this is where you actually start in terms of understanding transaction, validating a transaction, and creating a block. So let's go to Ethereum. This is one of the transactions that I picked. So you can pick any transaction basically. You can go here, pick one transaction. So this is the transaction that we have. It's a contract or it's a contract. Let's go back. It's again a contract. That's okay. That's okay. Doesn't matter. Cool. So this is your transaction information in Ethereum. And people understand Ethereum? Ethereum is an equivalent to Bitcoin blockchain, right? So what do we have here on a transaction? So you have a transaction hash, which is basically hash about this particular transaction, right? Transaction data. When I say transaction data. Right? You then have the block height, which is nothing but number of blocks preceding the current block. So on my network, there are about 5,54,000 blocks in front of the current block. Right? When did I validate this transaction? I got this transaction at that time, right? And somebody else would have got the transaction at a different time because of the geographical reasons. Where are we originating this transaction from? We are originating this transaction from this account. We are sending this transaction to this account, right? And then what is the token transfer? We are doing so much of token transfer, right? 200 bitcoins. What is the value of the ether? It is 0 ether, right? Actually, this is a token. This is a bad example. If you take a normal Bitcoin transaction, this is a contract transaction. It's again a 0 ether. Let's look at non-zero ether. I couldn't find one. Okay. Let's go back to this example. So I'm sorry. There is a So we sort till this point, right? We say it's a to address. So I'm sending this from this address to this address. How much value I'm sending? I'm sending about 0.02 ether. Oh, there's a feature here. Okay, I don't know how I got that, but that's okay. Sorry. Yeah. So there's something called gas limit. There's gas price. These are specific things about Ethereum, right? We will talk about the significance of gas and gas price for Ethereum, but in blockchain you would not see this. You would just see from where you are sending, right? And then you have a nonce, right? Nonce in this case is nothing but the number of transactions this account performed, the from account performed. The 0 indicates that this is the first transaction from that account, right? Why is that significant? We can probably go back to the other examples as well. Sorry, this is a Bitcoin network, right? So nonce here is 48. So the account, this from account has done 48 transactions, or 48. This is their first 48th transaction, or 49th, because we started with 0, right? 49th transaction. Why is this important? Can anybody guess? But why is that important? How many transactions I did? To audit, how can you? How are you thinking about audit? But how is that important that I have done 48? How do I know that I have sufficient ether? Right? Okay, that's one. There are more responses.
I mean, ordering something like that.
Ordering, that's one use case that you're thinking about. Fair enough.
Credibility.
Credibility is one answer that I got. Okay, so some verification purposes you're seeing. There's one more response there.
Reliable the node.
So it's not a node, it's a from address.
It's from address if the transaction is happening, the count is more than this guy is actually using Ethereum each and every transaction. So you can have more responsibility and more credibility on the account from the other account.
Okay, possible. That's a good idea. We can think about it. That's a good idea. That's one more way to establish consensus.
You can use it as a validation tool, sum up all the transactions and check whether they sum up to the correct number.
Okay, so that's one use case. But we don't have to do it for reasons that I'll tell you. So here, right, because of the distributed nature of the world, let's say I did 2 transactions. Right? There's no guarantee that my first transaction will reach you first, and then my second transaction. It can totally be possible that I can send the second transaction goes first to the node, and then the first transaction. So there is no way for me to verify that this is the correct order in which I am processing. Right? Somebody said order, right? So what I do is I keep a track of for this account what is the nonce that I have. Right? So I get 48. I'll see what is the nonce that I have. If it's 46, then I know that there is 47th transaction that's yet to come. So I'll hold on and not process this transaction. I'll hold on till I get the 47th transaction. Then I process the 47th transaction. Then I process the 48th transaction. Right? And you can see a flaw here. If 47 never arrives, all the transactions after that will never happen. Right? That's definitely possible. No, it's so this number is unique for an account. This is the number of transactions this account did. From account. Okay, so that's what I'm saying. So this nonce will be different from different accounts. For this account, right? Okay, good. Let's go back. Let's go back to this account, right? Let's see what do we know about this account. I clicked on this account. It says it has done about 54 transactions. Right? Some smart contracts maybe, but these are the transactions it did. So this number that we saw, the nonce number, it's unique for that particular transaction. So that particular account has done 54 transactions, but till now there are about 48 that got reconciled. And so this account, this 48 is for that account. It's not for, so for me, right? Okay, let me go back. Where can I find it? Sorry about this. So I did 2 transactions. I'm trying to pull that out, which can show you that your first transaction nonce was 1. The second 0. The second transaction was not 1. I'll try to find that in the break, and I'll show you. But so if you do one more transaction from this account, this will become 48. The other account might do another transaction, but this will only increase if you're sending some ether from that transaction to from that account to anybody else. Right? Okay. So let's take A. Yeah, so I'm trying to understand the question, right? So you are A, right? Can somebody give mic so that we can have a conversation and everybody will follow? A mic, please. The pace is okay, or you're finding it too slow? We need to do some course correction here. You're finding value in this conversation? Yeah? Okay. So can you stand up for the benefit of people? So, okay, so you are A, right? You're sending a transaction to me. So your nonce is 99, right? I see you on your t-shirt. Can you stand up, please? Right? So this is some of the transactions. It doesn't have a number, but let's give him 5, right? Okay. So you're sending some transaction to me, right? So you will say your nonce is 100. That's your 100th transaction. He is sending some transaction to me. For him, the nonce will be 6, right? So if you see the number, the nonce here in transaction depends on you, the sender. It doesn't depend on me, the receiver. Correct. So you track. Correct. So you track for what account, what is the nonce. So if I get, let's say I get 101, I know that from your what's your name? Shubham. I know that Shubham's number is 99. I got 101. It means that 100 is missing here. So I'll keep a track of it. Does that answer? Yeah, the mapping is there. Thanks.
Just to clarify, so does every node in the network having the information what is his number, nonce number?
So there are two kinds of nodes, full node and light node. Full nodes have all that information. Light nodes, because full nodes participate in mining, light nodes don't.
Okay.
So full nodes have that information. Yes. Correct. So your wallet manages it. Okay. That's a good question, right? Let's understand that question. The question is nonce auto-generated? It's not. Right? Let's take this example, right? Shubham has 99. For some reasons, he decides to send 101 to me. Right? What will happen? Yeah, the transaction will never be processed. Because I'll be always waiting for 100. Right? So the wallets that you have, the Bitcoin wallets or the Ethereum wallets that you have, they generate number for you. So that you don't commit human mistakes. Right? Your Ethereum, your wallets manages that for you. If you're using a wallet. Wallet keeps a track in terms of for each account, because a particular user can have multiple accounts. Right? So a wallet maintains all the track of which account has which nonce. So the wallet does that for you. But it's not auto-generated in that sense. It's client generated. Any more questions on nonce? Clear about this? Yeah. Correct. So, did you use, let's say, which was a P2P protocol that we used? BitTorrent, right? How did you use BitTorrent? It is the same protocol, right? The moment you are up, you can download from the latest tier that you have. Why you have to upload? Because your transactions will not be mined otherwise.
So you were saying there were 2 types of nodes, right? So
2 types of nodes. Nonce, yeah. The block nonce will go there. This is transaction nonce. Nonce means nonsense, right? That's what it means. It doesn't have any significance. That's why you use the nonce. There's no extreme significance to that. That's clear, right? With me so far? Okay. This is a typical transaction about a Bitcoin. We looked at Ethereum. Now we're looking at Bitcoin. These are the 2 major pictures that we see. So we are saying here the account, the Bitcoin transferred from this account to this account, right? Now, the way Ethereum works is Ethereum is account based, right? Somebody asked in terms of is this transaction valid or not, right? So in Ethereum world, it's very easy. Let's say I am transferring, let's say 2 Ether. I can go back to this account and see if this account has 2 Ether or not, right? If Ether is not there, I can't process the transaction. But Bitcoin does that a little differently. Bitcoin says it gives you input, it gives you total input, right? It gives you total output. So I am saying I have 0.532 Bitcoins. I intend to transfer 0.528 Bitcoins, and this is my fees. This is the fees for the miner who mines this transaction. Right? This is what I am willing to pay. Now I need to prove that I have this much input, because you have to say from where you got the Bitcoin. Right? So That's where you have this scripts, right? So basically, you have. So I think I can quickly show you that. I'll try to find a transaction which has that. Let's go to one transaction, right? Let's go to this. So for this block, these are the transactions that we have, right? The first one, the first transaction that you see, it always goes back to the Coinbase, which is your mining reward. Because you mined this block, you get about 12.8 bitcoins as your mining effort, right? So that's why you don't see a from. The bitcoin got generated now. New 12.9 bitcoin got generated now, and it's given to your account. If you see the next transaction, it's coming from two inputs going to this output, right? It gives you, and if you go back to this particular input, it will show you where you got that input from, right? And if I go to this transaction, sorry if I'm kind of going a little slow here, but I believe it's very important to understand how this whole thing works, right? So this is your input script, and this is your output script, right? So what are we saying here, right? Here, if you see here, you're saying this basically data that you have is nothing but my signature and my public key, right? This is your input, right? So let's take Sreedhar, right? Whenever I want to spend 2 bitcoins, right? How can I spend 2 bitcoins? I need to have 2 bitcoins, right? Let's take a real world example, right? You go to a grocery shop, you have 10 rupee note, right? You have 2 10 rupee notes, and you want to spend 15 rupees. How will you spend 15 rupees? You take 2 input, 10 coins. You never really bother where you got this note from. All you care about is this note. But in Bitcoin world, you need to care where I got this Bitcoin from, right? So I take 10 rupee note, give this to the business person. He'll give me back a 5 rupee change, right? So let's see how we do this in Bitcoin, right? So I'm saying I'm going to spend 2 bitcoins, but where I got those 2 bitcoins from? I got the Bitcoin from this transaction, and I got the Bitcoin from this transaction, right? Using the signature here, I am proving that I am eligible to spend this, right? As a miner, I can validate using a simple mathematics, hash mathematics. I can always validate that I am the person who actually can spend this Bitcoin. So these are the 2 inputs that I got, and I want to give this output to this account. So I want to spend 2 bitcoins in that account, right? Let's assume you want to spend 2 bitcoins, but you have 3 bitcoins. What will you have? So there will be one more output here. It's called change address output. It's like a change that you get. So you will give a new address, that is your address, to say the remaining 1 bitcoin, please give it to this address. Clear about this? So there are 2 outputs here. One output is the person that I need to go pay money. Second output is called change address, like your change, right? So the remaining change, please deposit to this account. Clear about this concept? And how does this work? So Bitcoin transaction has inputs, outputs. As a miner, you will validate sum of inputs, sum of outputs, match. Input validated, right? The next question is, what is the guarantee that I have not spent that particular transaction elsewhere? I need to know, right? How can I not spend this transaction twice, right? For that, your Bitcoin maintains a global ledger called UXTO, right? Unspent transactions. So it maintains a list of all the transactions that are not spent. So as a miner, I quickly go back and say, okay, this transaction, I'll go back and check, does this transaction exist in unspent transactions? Thumbs up. If it's not there, I'll say, no, you lied to me. You already spent this. So you can't spend it again. Fair enough? It's a simple concept, right? Yeah. So, yeah, one of the issues again with Bitcoin is the size, increasing size of, because you keep getting this change. Anybody has this problem of change in house? I maintain a thali. I keep putting changes in it, right? Obviously, it's a growing network. That's one more problem.
So I have a question here. So who is going to maintain that ledger of USDO?
Again, the full nodes.
So
the node on the network. Every single node maintains that.
So how come it is decentralized? Like we are again coming back to the same.
No, right? Every single node has that. You have it, I have it, they have it. There's no single authority who opposes it.
But still, I mean, still there has to be some consensus, right?
Correct. We'll go to consensus. We will have to go. Yes, we'll go there. Tell with me so far, right? You understand the Ethereum transactions? Ethereum is basically account-based transaction. You always know whether you have Ether or not. The Bitcoin is UTXO-based transactions. You have inputs, you have outputs. That's how you do transaction validation. Clear with me? Cool. Now, Now let's go to block, right? So the next aspect of blockchain is block, right? What is a block? Block is a set of transactions basically. One complete transaction? Okay, yeah. Yeah, so a block can be 0 transactions or more transactions. You can always do a zero block, 0 transaction block. It is also possible. Technically it's possible. You wouldn't want to do it, but that's technically possible. So let's look at this block. So what do I have the information here? So the information that I have is height. So how many blocks exist before me? That's first, right? The second one is when did I mine this block, right? Second one is how many transactions? There are about 158 transactions and there are about 9 contract transactions. We'll talk about smart contracts, but this is the Ethereum, right? So basically number of transactions that block has. In this case it is 158. The hash value, this is where the mining, okay, how much time do we have? 5 minutes. Okay, let's kind of shift the break for a minute. We'll talk about mining and then break. That's okay, right? Okay, fair. So these many transactions exist, right? There is something called uncles. Uncles is again unique concept in Ethereum. We will talk about uncles. That's related to Vishnu's question, right? Not Vishnu's question. Ashwin's question, right? About what happens when you have simultaneous transactions. We'll talk about uncles a little bit, right? Uncles are not important. Parents are important, right? So, next one is mined by who mined it. I can't zoom in, but I can get a real transaction. Let's see if I can find a real transaction. I took a screenshot from this site. So I go here, I take this block. Let's take this block. Let's take this block. It's visible now, right? Right? It's the same stuff. It's height, timestamp, transactions, right? Hash, what is the hash value? This is important for proof of mining. What is my parent hash? What is my previous hash? Right? SHA uncles, we'll talk about it. Mined by difficulty. This is the difficulty question that we have. Why this difficulty keeps increasing? Right? It doesn't keep increasing, it keeps changing, but we'll talk about it. What is the total difficulty? What is the right? What is the size? Gas. We'll talk about gas in a little bit. The nonce again came here. Let's talk about this nonce. Right? Let's talk about what is the reward for mining. I got about 3 ether for mining this particular block. Some extra data, right? Now let's understand. So if you go back to so if you go back to the Bitcoin block as well, Bitcoin blocks look similar to this. It should look similar to what it is, right? So again, what is the transaction fee? What is the height? What is the timestamp? What is the difficulty? Right? Similar set of data. So that brings us into who creates this block and how do we create this block? Right? That's where you have this concept called mining. So let's get into what a mining is. So for the sake of understanding, right? Your block is nothing but set of transactions. That's what you can understand. Right? So that takes us to mining, right? Somebody mentioned, right? Mining is a process of validating transactions and creating a block and adding it to the blockchain, right? And what do you get by doing that? You get some bitcoins or ethers for the effort that you spent, right? For you to do it, we need to agree on the consensus, right? That's where we go into the consensus in terms of how do I, as a decentralized system, how do I agree on agreement that this is a valid block, right? So we use, for the majority of the networks, blockchain and Ethereum, both uses the concept called proof of work, right? What does this mean? From an English standpoint, what does this mean? Proof of work. Agreement in what? In what agreement? Okay, so you see that as an agreement. Okay. Delegate. What does proof of work means? English, literal. Correct. Right. Good example is certificate.
Yeah.
Right. It's possible to get that certificate in America in 2 weeks. Right. But if you actually do the real work, this indicates that I've worked for 3 years. Right. For whatever degree. This is a good example of a proof of work. Right. The way we do it in blockchain network is Let's take this example, right? So I got these transactions. I validated the transaction. We understand the validation of transactions. I go back to my from account, see if there's enough ether, I approve the transaction. So I have a set of transactions that I have. Now I need to push this to the blockchain. So what I do is, I take the block header. What do I mean by block header? Block header is nothing but your timestamp, your previous hash, right? The example that we saw here. Right? Yeah, this. Your previous hash, your timestamp, your transaction root, the Merkle root, and the nonce, right? All together, put together, what I do is, there's a difficulty level that we saw here, right? There's a difficulty level. The difficulty level here is some number that I don't even understand, right? Some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 digit long number, right? So what I do is, I take this header, right? And I hash it, right? I get some hash number. So I hash it with, I'll start with nonce is equal to 0, right? I take this, I take nonce, combine them and hash. I get some number, right? I check if that number is less than the difficulty number, right? If that number is less than the difficulty number, that means I have mined, right? So if you see in this case, the nonce here is some huge number, right? So the person who has mined this, what they would have done is, they would have taken 0, did a hash, checked, it's not 2, 1, hash, checked, not 2, 2, hash, checked, not 2. You keep doing it till you find a number which is nonce, which when hashed with your block header, gives you a number which is less than the difficulty number of the network. Let it sink in. Clear about this? Okay, let's take a concrete example. Let's assume the hash of this, the whole block header was 2, right? I'll take 2, I'll 0, hash, I get a number. I'll check if that number is less than a difficulty level. So let's take the website that we saw. It actually gives you, there are two ways people explain this. One way people explain this is by difficulty level, right? The second way people explain this is the number of zeros it has, right? The number of zeros in the hash. But what does number of zeros indicate? 0 means it's obviously, so let's say 3-bit. What does the first indicate? First 0 means? Right, so I eliminated third bit. So the only possibility is 0, 0, 1, 0, 2, 0, 3, because it's always 0. I put one more 0, what's the possibility? Correct, 2 more, right? So it's same as checking less than the particular number. So if you put this 10 as, or 16, right? 9, right? If I put 10, the only possibilities are this block. So I'll have to have 2 zeros for this, right? So yeah, what I do is, that's why if you say the real mining is happening now. So what it is doing is, it is taking this number, it is taking a nonce. Let's put a 0 nonce. Everybody remembers this number, right? 13703. I take this off, 13703, right? I do mine. It actually took back to 1303. The answer would have been red. Then I say 1, it will not work. 2, it will not work. 3, it will not work. I'll have to do it 13,703 times to find a number which actually gives you a green. Clear? Right? So the way actually it works is, it goes 0 now, do a mine, it goes 1, do a mine, 2, do a mine, 3, do a mine, till you find 13703 number. Right? That's what is mining, right? So you find a nonce which gives you the hash which is less than the difficulty number, right? So let's go back to, people clear about this, right? Clear about the process of mining. It's nothing but finding a hash, that's it, right? Now, why we have to do it like this? Why is this significant? Now, this goes back to the question of why is this a tamper resistant? And this goes back to in terms of why should we maintain difficulty level? Those are the two questions, right? We will try to answer that and we'll break for a break and then come back and discuss the further things, right? Okay, so let's take this example, right? I have 5 bitcoins, or let's say Shubham gave me 5 bitcoins. Sorry, I got your name, so I'm using it. So Shubham gave me 5 bitcoins. I gave 2 bitcoins to Joseph. So how much bitcoins do I have? 3 bitcoins. I got greedy and I go and tamper Shubham's transaction and say Shubham actually gave me 10 bitcoins. So balance that I have is now 8 bitcoins, right? So for this to happen, what should I do? I should go back to the block which mined Shubham's transaction, mine it again, right? Come back to my block, mine it again, go to his block, mine it again. I have to mine 3 blocks to make this transaction valid, which we have done in our example, right? But because this takes a lot of time to find a hash, By the time I'm mining this, somebody would have found some other transaction and they would have added one more block to Joseph's node. So now what I have to do? I have to mine. By the time you would have found one more thing. Mine, it's not possible. Right? That's how it becomes tamper resistant, right? That's why you spending work is essential. If you cannot spend work and if you make it very, very efficient, if I have a supercomputer, I can quickly modify this before your computer modifies this. That's why adjusting difficulty is very, very essential. So there's an automated way this gets adjusted, roughly. So in Bitcoin network, if you're able to mine by less than 10 minutes, your difficulty level goes up. But if your mining takes 13-14 minutes, your difficulty levels come down. So the difficulty level is changed depending on the network performance. So you want to kind of keep it at a particular level, which is 10 minutes for Bitcoin and about 14 seconds for Ethereum. Right? Depending on the response of the network, we keep changing this difficulty. Clear about mining difficulty?
Yeah, so regarding this difficulty, you said you have a supercomputer and you can just like that. But the same thing, that's why he used introduce the concept of consensus. The person who has supercomputer, let's say, and all other have that much not much that powerful computer, still he cannot override any blockchain because of the consensus. If you do all the transaction and you broadcast it, okay, this is the solution, this is the proof of work, check it and give the consensus. If consensus are you get the consensus, then will you add to the blockchain? Now question is the same thing. He can do the mining. He can give all the solutions first of all because he has the highest computing power. Fine. It doesn't matter. The same thing. That for me, it doesn't matter my performance because the second person who is next to me, he has a supercomputer. He will do all the transactions, all the mining. But only thing I can do is to give the consensus. Thing is, if a difficulty level, either you increase or decrease, for that person it doesn't matter.
Okay.
The thing is, when all the peers, all the nodes having the same performance, then this, in the sense, increase your difficulty level.
Okay. Okay. So if I understand the question right, if I have the best computer possible on this earth, and I'm by far the fastest amongst the peers, right? How will I manage that? That's point number one. Second question is, where is the consensus concept coming here, right? If I am the one who is pushing the transactions fast,
you cannot do it.
Where is the with supercomputer, if you are able to do, where is the consensus concept coming from?
Yes.
Those are the two concepts, obviously, right? Now, if you see here, which is the doubt that you have, or the question that you have is valid, right? But it's very difficult to find a computer which is superior than the rest of the world, right? So right? So you have actually, earlier when we started off with Bitcoin, any computer would have kind of competed for mining. Now you have the ASICs, right? The chips that are burned specifically for mining. They would beat you normal computer and any which way. So mining using a normal computer is not possible. You will have to buy this specific hardware for mining because of this fast reasons, right? That particular computer can generate hashes much faster than a normal computer does, right? They have an advantage there. But there will be many such. But if you see, the majority of miners today are from China, right? The reason why they are from China is China has subsidized power compared to global. So they are able to participate more than other computers. So there will be advantages and disadvantages of the nodes on the network.
Yeah, because they're doing the pool.
Right, that's one point, right? So it's theoretically it's possible that I have the best supercomputer which can override anybody else, but practically it's not possible. You agree to that, right? So the next question is, where is consensus coming in this picture? We will go into what consensus. What is, when we say consensus, what do we mean by consensus in this scenario, right?
So if you do all the mining, let's say, still you cannot override anything.
You can, if you can. If you are the only one who keep mining it.
If you have 51% consensus, then you can override a whole blockchain. That's
right. So yeah, fair enough. 51 consensus in terms of validating the transaction. Okay. So we'll talk about validating the transaction, right? That's a very valid point. So his question is, I've heard that you should have 51% consensus to approve a transaction, right? So what do we mean by consensus and validating? That's a good point, right? So we what we did? So we took block header. block header, we found the nonce, we hashed it, and we generated something called this hash. I said I've done it. Now somebody needs to approve that this is a valid transaction. That's correct, right? So what will Joseph do? This is again a one-way function, right? Joseph cannot find inputs from this. But what will Joseph do? Joseph will take the block, right? Joseph now knows nonce. He doesn't have to find the nonce. He will say input, nonce, am I getting the same transaction or not? If I'm getting the same transaction, it means Sreedhar has done his work. He found this by hard way because there is no other way you can find it. You will have to do so many iterations. He can say, yeah, Sreedhar has worked. He will approve. Right? Shubham will approve. The moment I get 51% consensus, like, yes, this particular person has worked, that gets added to the blockchain. Right? Clear about that? I will repeat. So I took the block header, I found a nonce by doing repetition, and I computed this hash, the hash for the block. Right? And I propagate this to network. Joseph gets it, Shubham gets it. What will Joseph do? Joseph will take the block header, right? Creates a hash. I already gave nonce in my block, right? I said I use this nonce. He takes that nonce, just hashes it. He will get this particular hash. He says thumbs up. It's a very fast process. Shubham says thumbs up. Right? If there are 4 computers, I got majority. The block gets added. Clear about that? Yes, no, maybe. It's okay if you don't understand. I can repeat that. Silence is agreement? Okay, cool. Right. So, now, yeah. The network automatically decides it. There's an algorithm which sits on the node. Right? If yeah. No, it's specific to the network. Okay, I'll tell you what I mean by that. I mined, right? Let's take the average time for mining today for a Bitcoin network is 10 minutes. Right? I mined it in 7 minutes. Joseph mined it in 8 minutes. So network will say, okay, your mining times are going down. Which means I can do, if it keeps going down, and if it falls back to 1 minute, I can mine 3 blocks. So what will computer do? The network do? Network increases the difficulty. Right? Suddenly your processing time goes to 14 minutes, 13 minutes. Network will say, okay, I should reduce the difficulty. So it's like an equilibrium. Right? So you can actually see that code in the GitHub. You can go to GitHub because there's a Bitcoin core implementation which will tell you actually that where is the difficulty level adjusted. It's there in the code. Nobody does it. Code does it. The algorithm does it. In fact. Yeah, Bitcoin. Yeah, GitHub. No, for example, the Bitcoin core, the code is there in GitHub. For the Ethereum, there is Ethereum yellow paper specification. So the clients are again built. So you can always go back and trace, understand how the difficulty level works. It's there in public. It's not done by individual, it's done by computers, the algorithm.
As per my understanding, just there is no concept of the majority.
Okay.
Only the 100% is required. The concern is the 100% required. There is no concept of the majority. Whenever you go for any transaction, first it creates a quorum. Still, the transaction will not be complete when we cannot get the 100% consensus of the quorum member.
Quorum is 51%.
Yes, because just with every node, with every transaction, now the blockchain technology creates quorum. Suppose in the transaction, the 5 members are there. We need the authentication of the all 5 members in terms of the yes. Anyone says no, the transaction will not be complete and it will be create one node, but the transaction will not be complete.
I don't think so. I'll tell you why. I don't think so. Right? That's where we go into Ashwin's question. Right? So let's assume you are Japan and that's San Francisco. Right? You are like 2 poles apart. So Vishnu mines, who is sitting next to Ashwin, he mines a coin. Because of the network reasons, Ashwin would get the block mined by Ashwin, block mined by Vishnu faster. Right? Now you are in Japan, there's a node there. They would get your transaction, your mine, faster than Ashwin's transaction. Because of the network reasons, right? Travel, right? So now you have 2 blocks. Right? So both are real. That block is real, this block is real. Now what will happen? Next, somebody will find some transaction in the middle. They find a block, right? It's possible, totally possible, that either that particular block might reach you fast, this particular block might reach you fast, right? the moment you get a block, you will say, let's go with Vishnu's block or Ashwin's block, and you start mining on top of it, right? So whatever chain wins is the longest chain on the network, right? For instance, what's your name? Sandeep? Yeah. For example, Sandeep chose Ashwin's block, right? So Ashwin's block will be the winner because there are 3 nodes on the network, whereas this has only 2 nodes. Right? So that particular chain wins, and everybody on the blockchain will start using Sandeep's chain and kind of work on that. So they will dump the chain, that chain, and move on.
So far, just we create the separate quorum for every transaction.
What do you mean?
Just suppose in a chain, suppose in a blockchain, 100 members are there. There is no need to consist of 100 members.
True.
Now the transaction is going to be and you. The 3 members will be inside the quorum for the particular this transaction, and we create the structure of this main quorum.
But I can't add to the main network. That's correct. So your transaction happened. So let me kind of rephrase this, right? So there was a block. Everybody knows this is the right block, right? You mined on that block, create a new block, right? There, Ashwin mined on that original block and created his own block. As you rightly mentioned, I push this block to network. It's a P2P based. Everybody will start getting those blocks, right? So Sandeep chooses now whatever blocks he needs to mine on, right? Depending on what Sandeep chooses, that becomes the longest block of the public network, right? And that particular longest block of the public network becomes the blockchain. That particular block that you created will be dumped. But you will not lose transactions. Why will you not lose transactions? Because the same set of transactions you would have seen, and the same set of transactions Vishnu would have seen. Right? They would have mined it in different orders. Your block hash may be different, but you would have same set of transactions. So you would not lose the transaction. Right? So what happened to that block which was not mined? What will happen to the effort that person has produced? In Bitcoin network, that's lost. They will not pay for that particular work. Whereas in Ethereum, that particular block is called uncle. Right? So we give some aspect of my mining to uncle because he spent some energy. So we need to reward because of he spent that energy. Right? So advantage with that is, if Sandeep chooses to mine on 2 blocks, because you don't know which block, which network will approve. So Sandeep will start mining on 2 blocks, and then whatever majority users, he'll go to the network. Right? So that's why Ethereum kind of helps you. You have this concept called uncle there, where you get some payment because of the effort that you put. So the other last slide, and we go for break. Other way you can do this is consensus is called proof of stake mechanism. This is proof of work mechanism. The other way is proof of stake. Proof of stake means I am willing to stake 100 Ethereums on this transaction. So because I have so much stake, I will get this opportunity to mine it. Right? And if I do something wrong, those $100 Ethereums would be gone. 100 Ethers would be gone. Because I am putting so much stake, right? I have the opportunity to reward. There's no computation here. There's no you don't need to expend that work to give your vote. I can give my vote by putting stake. But again, there are problems. The problem is, if I have the most money, I will get the most opportunity. It's still in beta. If you're interested, you can go back and read about Casper protocol for Ethereum, which uses proof of stake. Ethereum is planning to implement proof of stake. I don't have the enough details to explain how that actually works on Ethereum. But that's other opportunity. The other way is proof of authority. You identify one authority as a network, that authority approves it. Again, it goes back to centralized. Okay? So currently, the only way it works is proof of work. But we're talking about future. Why? We'll talk about scalability issues of Bitcoin. But I'll kind of break here, unless anybody has any questions that we need to ask without losing context. Right. You have a wallet. In that wallet, you will select from account to account, you will say 5 minutes and transfer. I mine it. That's correct. Any more questions before we break? Okay. People can choose to walk out, right? You don't have to stay. You are not obligated to stay here. You can kind of break and come back.
For my basic understanding, 100 years down the line, is it a sustainable?
Right. That's a question we are going to talk about. It's called scalability issues with blockchains. We will talk about that. Yeah. Right. That's not a problem in real world. Theoretically, yes, it's possible. Hash collection is possible. It's very, very rare. People choose to live with that. It's like living with fake currencies. It's possible. They live with that. This is no answer to it. No. So you will say, I have done this. This is the hash, and this is the knowledge. Right? I, as a validator, I'll take your hash. I'll take header hash. Okay, we'll get started now. So if you have any questions, I'm happy to take that after the talk. So yeah, please do stay back if you have any questions. Yeah, please. So we were here. We were talking about proof of stake. We quickly mentioned proof of stake, so we will kind of move it from here. Okay. Right. So let's go into the next concept, which is called smart contracts. This is again specific for Ethereum, but there is also a network called Hyperledger, if you are following, right? Hyperledger also has this concept called smart contract, right? So this kind of takes us into the conversation where we are talking beyond cryptocurrencies, right? Whatever we talked so far would work if the only purpose of blockchain was to do some currency transactions, right? But if you want to develop software on it, how will you develop software on it? So that's where you have this concept called smart contract, right? So what is a smart contract? Smart contract is nothing but a piece of software which is deployed on the blockchain, right? You can always invoke this particular smart contract. By invoking smart contract, it will modify the blockchain depending on how you coded the smart contract, right? Let's take an example, right? I created this smart contract called donation smart contract, right? Anybody who want to donate can call this smart contract and say, from my account, which is A, give 5 Ether, right? So what inputs I have to give? I have to give my address. I have to give 5 Ether. If I give these two inputs, I would have given the 2 address in the program, so I can't change it, right? The moment I call this, what it will do, it will take and it will create a transaction from your account to my account using 5 Ether. That's what smart contract does. Clear about that? Nothing really fancy, right? It's a contract between 2 people, which is a smart contract deployed on the blockchain. Right. So now we go into the applications of blockchain. Right? When we go into the applications of blockchain, this is the characteristic of a blockchain. So what is the characteristics? It's a decentralized, tamper-resistant, neutral platform that can establish trust in a trustless environment. Right? So I go again. It's a decentralized network. Right? There's no single master. Tamper-resistant. You can't tamper it. We just saw how we can tamper it. It's a neutral platform. You don't discriminate based on any issue. Today, Visa discriminates, right? For example, Visa issues a credit card only for certain income levels. Anyone who has income level below that cannot participate in a transaction. Whereas this doesn't discriminate. As long as you have computer, you can participate. Right? And then it can establish trust in a trustless environment. For example, nobody trusts, for example, take this room, right? People cannot trust each other. But we can establish trust in this network by proof of work to use this network for trading. Clear about these characteristics? So now when you have a business question which needs any of this, right? it's a decentralized system we need. We saw an example. We were having this conversation where they were building a drone-based network. For them, decentralized was more important. So we were also having a transaction with somebody on the financial sector. For them, tamper-resistant was more important. Right? We will see some use cases where establishing trust becomes more important. So those are the three characteristics that you would use blockchain to solve business problems. Clear? One application. So any examples that I am giving, please don't think these are good examples. These are the examples that I could find. Don't go and start invest in this. Right? I am not responsible for the money that you would lose by investing in this. These are some examples that I found. So use your caution. Right? The first example that I saw is Gitcoin. Right? Let's take the business problem. Business problem is Joseph is maintaining Freedom Box, which is an open source software, right? And he has a lot of problems, issues that he wants people to solve, right? Then you have a developer. What's your name? Abhishek is a developer, right? He is willing to work. Now, Abhishek doesn't trust Joseph. Joseph doesn't trust Abhishek, right? Joseph don't want to pay money because we don't know if Abhishek is going to solve the problem. Abhishek is not going to work because you don't know Joseph is going to pay the amount. Right? How do you solve this problem? This is a network that you don't have trust, but you can use blockchain. How you do that is, what will Joseph do is, Joseph will create a smart contract and pushes to the Ethereum. So the smart contract would say, any merge that goes into my Git network, right, send 10 Ether, would be a smart contract. Because you push this to the blockchain, you can't modify it later point in time. You never cannot change, go back and make it $5 or 5 Ether. Right? It because you pushed it. Right? The moment Abhishek solves the problem, submits the pull request, Joseph merges it, then you would invoke that smart contract and Abhishek would get 10 Ether. So you establish trust in this network. This is one example of a blockchain where you solved a problem that you couldn't solve. Right? Again, the importance here is there is cryptocurrency. Right? Again, the monetary benefit, again, the motivation. You need to have that, but blockchain is giving you the platform to establish the trust. So we are using the trust aspect of trust and tamper-resistant aspect of the blockchain. Clear about this example?
I have a question.
Yeah.
So in this example, I am the one that is paying, and I wrote a smart contract.
Correct.
So if I just I still have the contract, but if I just drain my account and transfer everything to another wallet,
you can't drain your account because that will be a transaction.
So like the account that is written in the smart contract, I can not have money in that, and thus
I think when you do validation, that's when you were seeing some transactions and smart contract transactions. I guess they would validate what are the smart contracts that are deployed using your address, and they would make sure that probably, I don't know the answer, but I assume they are doing it.
Like holding the amount, smart contracts.
I don't think they hold the account, but any transaction that you submit, right? I go to this account, I will see what are the smart contracts that are deployed. Right? I will get some X amount, right? Plus the transaction should be greater than the current balance. It's a relatively simple math.
Now, in real time, this will not work out, is what I'm saying.
Okay.
So my smart contract says I pay 5 Ether per commit.
Correct.
And he actually makes 3 commits. And for the third commit, I don't have money to pay.
No, right. So that's where you actually have gas price. We will talk about that. But you will approve you could have written code where it's auto, like every commit would send the money, but that's a bad implementation of smart contract. Maybe you want to have an approve mechanism where you approve the transfer. Right? It's a logic on how do you build that smart contract, which is viable for both.
Then I can violate it, right?
No, you cannot send it, but you can always go back and say this is the smart contract, right? So here, right, you will have to go back and see how they are doing it in real world. I don't have enough details about how Gitcoin actually works, but there are actual Gitcoins that are being sent, so maybe we can get into details. I don't have the details to answer the question, but the mechanism it works is this way. You deploy a smart contract. There is also, if you go back to the tools here, they are also talking about giving tips. So there are different platforms that they are building. Maybe I can go back and explore more about this and give an answer to that. I don't understand it enough to, but that's a valid question, right? You can't. Correct. That's the one problem that we have with tamper-resistant nature. We are all software engineers. How many of you have written software without a bug? First deployment, no bugs. Not possible, right? That's a problem. Now, how do I handle it? I push the smart contract, but it has a bug. How do I solve it? We don't have an answer. You can't mind the whole thing again, right? It's gone permanent. Now I have to write one more smart contract which nullifies that particular bug, and I should make sure these two smart contracts are called. And that's one challenge that we have. It's a good and also the problem in this case. Second example that we have is called Namecoin. The problem that it tries to solve is today DNS name is regulated. Only few people can give you DNS names, right? So what Namecoin is trying to do is it is making it decentralized. So you can request a domain name, right, and you can submit particular fees, the Namecoin, and you will get the domain name, right? So there is a browsing network that you can use. You obviously you cannot use the current DNS. You will have to use the alternate DNS, which is the Namecoin DNS. But that way you cannot. It's censor proof. It's censorship proof, right? Nobody can stop DNS registration because it's decentralized network, and if you get your approval, you get a domain name. Clear? People understand DNS, right? Yeah. It's okay if you don't understand. Please ask if you're not clear. The third example that I'm going to talk about here is Everledger. Right? This is one more example. Right? Everledger solves this problem of illegal diamond mining, illegal diamond trafficking. Right? We know there's a lot of crime in the diamond industry. We keep changing the certificates. Right? So what does Everledger trying to do is a diamond has special characteristics. When you put a light at a particular angle, the spectrum that it creates is unique. So what they're trying to do is they're trying to register the movement of diamond from where it mined to where it is going. That way you can always validate that this particular diamond is a clean diamond and it's not a blood diamond. Right? So that's a use case that these people are trying to solve using Everledger. Yeah? Because you cannot change it, right? That's a tamper resistant nature. This is one example. It's called Filecoin. What they're trying to solve is they're saying I can create a distributed file system, right? Because you are host, if I want to participate in this, I'm ready to give my hard drive, right? And because I'm giving my hard drive, I'll be given some file coins. So as a person who has an ideal computer in my home, I'll turn it on, let the people put files in this. For that, I'll get file coins, and this becomes a distributed file system, large-scale distributed file system, right? BitTorrent, but with monetary benefit. And obviously, because it has to tamper resistant, you can't modify the file contents. You guarantee to get the file content that you kind of submitted, right? Clear about the use case? So these are some of the examples that I found on the internet, which were interesting. But if you are following this space, you would have heard about the term called ICO, right? You have IPOs, your initial public offer. Similarly, you have initial coin offer, right? I come up with a business case, I float coins. I'll call them as Sreedhar coins, right? And people who are ready to invest in my idea, I'll distribute some Sreedhar coins, and I'll say you can start using this later, right? So if you go to that space and follow, you'll find hundreds of business cases. Most of it would be rubbish, few would be good, right? So those would be a good source to find out use cases of blockchain, right? And what do you look for in a good ICO? You would go back and look for those characteristics. One. Second, you will want to look for is, do they really need to have their own currency? Or can they not use their Ether and Bitcoin? Right? For example, in Filecoin, probably it makes sense to have Filecoin. I cannot use Ether because probably that coin is probably in my blockchain logic. So I need to have my own currency. If there is no reason why to have my own currency, you probably don't need your own currency. You can use Ether or Bitcoin. So those are the kinds of things that you may want to look for on what's a valid ICO, what's not a valid ICO. It's initial coin offer, right? So those are some of the applications that I found. Then I want to move into challenges, but just wanted to give you some flavor of what are the examples that people are using for blockchain. Right? No, there are blockchains, but cryptocurrency is needed because for the blockchain to run, which goes back to my previous slide in terms of role of a cryptocurrency in a blockchain. Right? For example, take this blockchain. Right? What nature of blockchain do you need? You need distributed nature. You need tamper-resistant nature. Those are the two natures that I need. Right? And also trust. Somehow I need to trust that you will not do anything with my data. Three characteristics are needed. Do I really need a Filecoin? I don't know. Can I use Ether for this? Possibly yes. Then I don't need a cryptocurrency for this blockchain. But still, there's cryptocurrency in this blockchain, but this is not the cryptocurrency for this blockchain. You're using some other cryptocurrency, right? You still have benefit, but you don't have a token. It's not a ban in that sense, right? It can come under that, but the problem there is, I don't think government would want to lose control. They would still want to have a centralized clearing agency. So probably government will not use blockchain. They may use blockchain, but they may use private blockchain and implement proof of authority consensus. There will be an authority who will clear so they will not use proof of work consensus. Right? So there's a lot of work which is happening on private blockchains. People are implementing private blockchains. Clear about using this. So let's talk about the few of the challenges. We intend to close this by 8:30, 8:40. Right? People who are leaving, please collect the feedback and give the feedback. Point number one. Point number two is, if you're not registered already, please do register, because we want to share the content that we've used in this and keep you posted in terms of the events. 2 announcements and okay, we'll move on. Okay. You don't have to stay for the whole talk. Okay. Lot of people ask this question, right? If we see 10 years down the line, will this be scalable? Right? What are the challenges that we see with scaling? Challenge that we see with scaling is your block size is increasing, because a lot of people are using this for transactions. Your UXTO size is increasing, unspent transactions size is increasing. So you expect your full node to, and we are saying today's blockchain size is 30 gigabytes, right? So you need to have a beefy computer, and you have UXTOs are in RAM. It's not in hard disk. So you're looking for a beefy computer today to mine, right? So the initial thought behind blockchain was anybody should be able to mine, right? But slowly we are going to a place where only few people can mine. So that's the current problem that we have with the hand. There are a lot of thought behind how do we solve this. There are basically two schools of thought which is trying to solve this. The first school of thought says increase your block size, right? Because if you typically take a particular block mine takes 10 minutes, right? And if today the limit is 1 megabyte, now if I have to mine 2 megabytes of data, it will take 20 minutes, right? But if I increase the block size to 2 megabytes, I can mine the whole thing in 10 minutes, right? But the problem there is your full nodes will have more data to process. Your full nodes should have more data to put that particular transaction memory and do validation. That's point number one, right? Second, it will also introduce latency issues. As the size of the block increases, the latency on the network will increase, right? So the miners in China are opposing this, because the advantage China has is energy efficiency, but the disadvantage they have is the network latency. Americans have better network latency, right? So increasing block size would help American miners, but will not help the China miners, right? So there's some issues with taking one approach. So the other way to solve this that people are talking about is called lightning network or off-chain transactions. This goes back to one of the questions somebody asked, right? This was, I think, before the talk. So the lightning network or the off-chain transactions, what do we mean by that is, we don't have to put everything on the blockchain, right? So Joseph is a party and I am a party, right? Let's take multiple commit issues, right? I don't have to put every single commit on the blockchain. What I'll do is, I'll create this small piece of that main network. We do transactions independently. Nobody needs to approve it. Me, right? And then we ultimately put the result back on the main network. That way the end result is put in the blockchain, but not the normal transactions, right? You don't want to put 0.0001 V on the blockchain and it's not adding value. But we haven't found a solution which is implementable today. So the blockchain world, the Bitcoin world is split in terms of how do you solve this problem, right? Ethereum is going with proof of stake, which will get us solve some of these problems. But we don't have, so the gist of the story is, we have a problem, we don't have a solution yet. Currently there is argument about what is the solution, and we don't have a solution yet. If you are a cryptographer, if you have good cryptography knowledge, it's a good time to get on to this discussion and try to solve it. So this is one piece of puzzle which is not solved, still open. The second challenge that we have is pseudo-anonymity, right? We believe that the transactions that we are doing on Bitcoin is anonymous, right? There's no way you can track back that this particular transaction is done by Sreedhar. You can always track back saying this particular transaction is done by this account, but you cannot track back to Sreedhar. Now the problem that this offers is it's actually not very true because of the amount of monitoring that's happening across the world, right? It's not possible, right? If somehow by using web tracking, whatever user behavior, if somebody can find out one account, as a user I have multiple accounts. If somebody able to find one account which is related to me, they're able to crack. And they have done. There are proofs in Bitcoin network where people have cracked in terms of who was that person who did the transactions. So we think it's anonymous, but it's not truly anonymous. It's pseudo-anonymous. That's one challenge, right? That's why we talked about change address, right? So one of the recommendation is don't use the same change address for a lot of transactions. That way people will be able to track you that these set of accounts belongs to this particular change address. Variant kind of does that for you. Variant kind of keeps changing the address, but point to watch out, right? So it's like you are not anonymous. That's one challenge. People are solving this problem by using solutions like Zcash. So there's a new concept called Zcash, which claims to be perfectly anonymous. It uses a concept called zero knowledge proofs. Zero knowledge proof says, how can you prove somebody that I have done this transaction without actually revealing the transaction details? Right? So there's an interesting study. So you can kind of go back and read about zero knowledge proofs and Zcash if you are interested in the anonymous transaction space. The third challenge that we are currently having is the energy efficiency that we're talking about, right? So what we are saying is by 2020 or 2030, the whole Bitcoin network would consume the power equivalent to Denmark country. So the process that we have is not very energy efficient, the proof of work algorithm. So we need to solve that problem, right? So the proposals that we have on the table, it's proof of stake algorithm, where you don't have to spend energy to give your vote, right? So that's one more area that's still not solved, right? Ethereum is going for proof of work using Casper algorithm, but still an area where you want to go back and spend time. That's one more challenge that the Bitcoin network is currently facing. Another challenge, it's very, very nascent, very, very early, right? Things are changing a lot. Classic example, right? What happened, I think it's back in 2013, I believe. What happened was, we've talked about the example that Ashwin asked, right? If I have two chains, right? It's called one level fork, because at one level you have two transactions. Somewhere in 2013, I believe, they changed the underlying database for blockchain, which needed your hardware to upgrade. But half of the blockchain upgraded, half of the blockchain did not upgrade. Because of this reason, the split went up to 26 levels. So you had 26 different levels of blockchains running, right? So we will hit such issues. For the size scaling issues, right? The blockchain is trying new solutions. We don't have a solution yet. So the blockchain is very, very nascent. So things will change. We don't have a robust platform on which we can build solutions. So it's very, very flaky. Like now we are talking, there's a lot of things that are already changing. So a lot of things that I said might have been false now. Because whatever I'm saying is based on my research of last month. Things would have changed by now. Right? Some things would have changed. So it's very, very nascent stage. People are talking about quantum computers is coming, right? Once the quantum computer comes, we talk about breaking cryptographic hashes. The moment you can break cryptographic hashes, the whole thing will fall apart, right? The moment you can take the account number back from the hash, the whole thing will fall apart. That's a looming threat. There are work happening in terms of how can you create crypto-based blockchains, but there's one more challenge that this blockchain currently faces. Right? So those are the kinds of flavors in terms of challenges that we are facing on the blockchain network. I think I'm almost done. So this is my last slide, I believe. So as a developer, if your question is what should I do? Most important thing is be interested in this space. There's a lot of stuff happening in this space. Do read up, there's a lot of stuff, there's a lot of resources. Be interested, understand the basics of cryptography. How does hashing work? How does public-private cryptography works? Pick a particular blockchain. I picked up Ethereum. Ethereum sounded interesting to me. You can pick Hyperledger, you can pick whatever blockchain, and start building some apps on that. Right? There are some interesting challenges, right? Let's take an example of Twitter. Right? We have a lot of issues on Twitter saying Twitter is you can restrict somebody to tweet on the right. You can avoid somebody to tweet. So you would say I can build a decentralized Twitter where nobody can stop anybody to tweet. And because nobody can identify me, I can tweet openly. That's also a very interesting problem, right? But if you take the real use case, right? Now, if I have to tweet, what am I doing? I'm committing a transaction. Because I'm committing a transaction, I have to pay. How many of us would like to pay for a tweet that you want to do? We don't have a business model yet, right? So try to build some applications so that you understand the business use cases where you can build blockchain and then you cannot use blockchain. Build some apps. They're called distributed apps. So go and play. There are a lot of test networks where you can deploy. I deployed a smart contract on an Ethereum test network. It's free. So you can go play. There are a lot of stuff that's available. There are a lot of programming languages on which you can program smart contracts. Solidity is one example which Ethereum promotes. There's Viper. So there are a lot of programming languages. So pick a language. You can also program this in JavaScript. There is a library called web3.js where you can use web3.js to interact with Ethereum. So pick a language that you are comfortable, start writing some hello world programs. So those are my recommendations based on whatever time I've spent on what you can do about in this space. These are the resources that I have used. I'll share this after the talk. So this guy, and Andreas Atonopoulos, right? I found this guy to be really, really interesting. He explains the concepts really, really well. He makes it very, very easy. I would definitely recommend you to go and read the original Bitcoin paper, white paper. I would definitely ask you to go back and read the Ethereum yellow paper, beach paper. Right, so I kind of added some references here. I kind of got interested in this space by listening to a podcast. They have a lot of good content, so go back and listen to those. I think I'm done with whatever I needed to present. Now the forum is open for discussion, Q&A. Right. Correct. So there is no answer to it, right? The question that I would ask, this is in my opinion, I'm very, 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 very nascent in this space, right? My opinion is, the question that you need to ask is, do you really need to have to float a currency for this? The example of Filecoin, right? Do I really need to have a Filecoin, or can I use Ether? Right? If I can use Ether, then the only reason why you are floating coins is for making money and moving on. No, right? You're not exchanging because there is no Filecoin anymore. The only way I am paying for the people who are storing files is using Ether. There's no Filecoin anymore. So there is no exchange, right? So there's no, yeah. So there are a lot of ICOs which will dump, right? So true. So there's no neat way to identify. You got to be little. So probably some of them in the references would know better because they would have spent like 6-7 years in the space. They would know better. But for people like us, I think you'll have to go back and do some reading and use your judgment. There's no one way to identify that.
I have a question.
Yeah.
Excuse me.
Yeah. Okay. Yeah.
So what will happen?
I'll come back to you.
If more than one people give proof of work in the same point in time?
Correct. Yeah. So that's where you call it as a fork, right? There are two realities of block now, right? Now whoever mines the next block on will be the real block. Two blocks. Randomly, if somebody chooses this block to mine on, when you say mine on, you need to add block on top of this block, right?
Will that block be added in the main ledger?
That's what I'm saying. It depends on which block it's getting added on. So your main ledger keeps changing. I see what your question is. Your question is, will these two blocks be added simultaneously? No. No.
Blocks cannot be added.
Simultaneously.
It
No.
has to be one block only.
Because both of them can have same parent hash.
Yes.
And you cannot have same parent hash. So the network will wait for the longest chain and add it to the main network. Okay, so let's take this example, right? So you have to get it.
Is it a sort fork?
Sorry?
Is it a sort fork?
Soft fork? No, soft fork is different. Soft fork is, the example that we have for soft fork is, I'm a client, right? Do I need to update my version to remain on blockchain? If the answer is yes, it's a hard fork. I need to update myself to remain on the blockchain.
Can you come here, please?
Right. So there is some change in the mainnet. As a client, I need to update myself. The question is, do I need to update myself to remain on the main network? If the answer is yes, it's a hard fork. If the answer is no, it's a soft fork. I can still not upgrade myself, but still mine. That's a soft fork. Example is, there is a concept called segwit, right, where they are trying to solve the problem. It's a soft fork. As a client, I cannot support segwit, but still mine. I can choose whenever I want to upgrade, but I can still work on it. It's like a backward compatible change. Any backward compatible change is a soft fork. Any backward incompatible change is a hard fork. This is your chain fork. Yeah, I'll come back to you. There was a question there. I'll come back to you. Yeah.
Sorry to interrupt. Sorry. If we are till late, can we please take the questions offline?
Okay, so we can call the session off formally, but we can open for whoever wants to remain back and ask questions. I'm willing to answer those questions, but officially the talk is over. Right? Thank you. Yeah.
Thank you, Sreedhar. It was very informative.
Oh, thank you. I get some excited for mining. Okay.
We've not talked about how trading these coins is related to the whole blockchain.
Right.
So we hear a lot of buzz about trading of the Bitcoin.
Right.
I would like to understand the relation.
So I am very poor at that. For example, the only shares that I brought were the shares that I got when I joined in my organization 30 years back. So commodity trading, I'm really pathetic. So I can't advise on that. But if your question was how does that work, I can answer in terms of how does that work. But what coins should I invest on?
No.
Okay.
So with the trade, actually, with the demand, the price keeps increasing. Right?
Correct.
So I mean, is that like I'm just trying to understand. So you've explained the whole thing about how blockchain works and everything, but we've not touched anything about like what is the maybe if I could think out loud, maybe because the price is increasing, that is why people are getting